Hey everyone, Mr. Scullin here. We're back at it, lesson 2 in unit 5 today. We're going to be talking about simplifying radical expressions. This is something you have done before. It's going to be really important that you understand the concept of simplifying radicals because it will apply directly to the new information that you're going to receive today. So what I'm going to try to do today is tie in review with some of the new content that you're going to get so that you can kind of see how the concept applies to what we're going to do today, the concepts from Algebra 1. So let's talk about a little bit of terminology, and then I'll probably back up and do a couple basic problems from your Algebra 1 days to kind of get you back into the group, right? So when we look at this, we have a bunch of different parts. We have this number right here is called the index. Now, here's a point in case where I'm talking about review. In your Algebra 1 days, we just did square roots, right? Like the square root of 4. Now, technically, there's a number 2 right here, but because we call it a square root, we don't put the 2 there, all right? But once we get above 2, like 3 and 4 and 5, we put that number right in that space when you make your square root symbol, right above the first part of your square root symbol there. That number is called the index, okay? And what does that do? Like when I take the square root of 4, the square root symbol means what? And this is what I was talking about in terms of understanding the concept. What does the square root symbol mean? It means what times what will give you the number that's underneath the square root symbol. So like when I take the square root of 4, I know that that's 2 times 2, so the square root of 4 is 2. All right? And because 2 times 2 is 4. So that's what this symbol means. So when you look at something like this, which says you would pronounce this as the 4th root of 81, what you're trying to figure out is what 4 numbers would multiply together to equal 81. The 4th root of 81 is 3 because 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So whatever the index is basically how you're going to group the number that multiplies by itself to give you the radicand, is the technical term, the number underneath the square root symbol. That's called the radicand, okay? Obviously you have your radical sign, which you know what it is, and then this is called, the answer that we get is called the principal root, okay? And the reason we call it the principal root is because if you take the 4th root of 81, you will get 3. But negative 3 also works, right? Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 would be negative 27. And negative 27 times negative 3 is still positive 81. So the principal root is always positive. If I want, or the textbook, or your homework assignment, or quiz or test wants the negative root, we will place a negative sign out in front. Think of it as like a negative 1 times the 4th root of 81. That would give you a negative 3. If there's a plus or minus sign out in front, that again, just treat that like a plus or minus 1 times, and so you'd have plus or minus 3 here, all right? But we want the principal root. So hopefully that recalls your memory a little bit about square roots. The other thing I want to do real quick with you is work in some variables. So I'm going to switch to blue here. And I'm going to switch to variables. So if I take like the square root of x to the 6th, I want to review this just a bit. So the square root of x to the 6th, well, what's really here? There's really a 2 here, even though that'll never be put there. So what you're thinking is, what 2 terms get multiplied together to give you x to the 6th? So you have to go back and use your knowledge from lesson 1, which is all a review. And that would be x to the 3rd, right? Because x to the 3rd times x to the 3rd is x to the 6th. When we multiply exponents, we add, right? Or when we multiply these, we add the exponents. 3 plus 3 is 6. So the answer to this is x to the 3rd, okay? If I take the square root of a to the 8th, again, in your mind you're thinking what 2 terms multiply together to give you a to the 8th, which would be a to the 4th. And so that would just be a to the 4th. Now you may see a little pattern here, right? What's 6 divided by 2? 3. What's 8 divided by 2? 4. And so the shortcut to these is basically whatever, if you have a square root, these are square roots by the way, because there's a 2 there, whatever this number is, like 8 or 6, you just divide by 2. So now you may be thinking, well, Mr. Scullin, what if you get an odd? So what if you have x to the 9th, let's say, and I want the square root of that? Well, you're not going to get two things that multiply together to give you 9. So what we do is this. Again, remember, there's really a 2 here. And so it's just kind of like breaking down. You remember when we broke down our square roots? So you would be looking for pairs of 2's, right? Or pair of x's. So you'd have x, 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 x. That's 2, 4, 6, 7, 8, and 9. Well, how many groups of 2 do we have? We have 1, 2, 3, 4. So we have x to the 4th, and we have a lonely x by itself. Well, if you remember when we used to break down numbers like 12, what would we do? We'd go 2, 6, 2, and 3. What are we looking for? We're looking for pairs of 2's, right? Because there's really a 2 there. That number indicates what you're looking for. If it's a square root, that means we need 2 of these. Okay, so that'd be 2 radical 3. What did we do with the leftover 3? We put it back underneath. So basically, you got 1, 2, 3, 4 groups of 2, and then you have a leftover x, and so that would go right there. Okay? The other way you can think about that problem is take 9 divided by 2, which is 8 with the remainder of what? 1. So it's essentially essentially what this is doing is you're basically saying the square root of x to the 8th times the square root of x. That would be x to the 4th and x left over. You can think of it that way as well. Okay? All right, let's move on here. So before I move to the next page, we were talking about the principal root before I started talking about variables. We were talking about the principal root always being positive. And so I want to talk about a situation where that might not always be the case, and I'm going to do that on the next slide. So what I'd like you to do right here is try these examples on your own, see what you come up with, and then hit play and we'll resume the video. Okay, so the cube root of negative 27. In your mind, this is conceptually what you should be thinking is what 3 things multiply together to give you a negative 27? Well, negative 3, and negative 3, right? Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. So the actual answer is negative 3, because I know that negative 3 times is negative 27. Notice some of you are looking at this problem right here. You see this 27 and you see the square root sign and you're thinking this. Hey, Mr. Skelton, where's I? I can't take the square root of a negative 27. Aha, you're not taking the square root. You're taking the cube root. The cube root. So it's different, all right? Because I do have 3 numbers that multiply together to give you negative 27. Okay? The cube root of regular 27, again, what 3 things multiply together to give you positive 27? That's just plain old 3, right? 3, 3, and 3. Okay? This represents the 5th root. So when you take the 5th root, you can really rewrite this when you have a fraction. It's the same thing as thinking about it like this. The 5th root of 32. So you're thinking, what number multiplied 5 times gives you 32? Now, I'm going to show you how to do this in your calculator as well. There's a couple different ways you can do this. If you look right above your caret button, I don't know if you can see that, right above your caret button you have a symbol that's got a little x with the square root symbol. So if I want to take the 5th root, you type in 5 first, then second caret button. So now in your calculator, ooh, that glare is pretty nasty. You can see I have 5, which is in place of that x, so I have the 5th root, and then I just type in the number 32 and hit equals 2. And that makes sense because 2 multiplied by itself 5 times gives you 32. You're taking the 5th root of 243. So you'd go 5th, second caret button of 243, hit equals, and you get 3. So the 5th root of 324 would be 2/3. You could also type that in all at once. You could go 5 second cube or 5th root, and you could just use parentheses and go 32 divided by 243. Oops, missed my division sign. 32 divided by 243, and just hit equals, and it should give you 0.6 repeating, which is 2/3. Okay. Solving for x at the bottom, we know this by now. we're square rooting, so we get x equals plus or minus 5. Remember, when you're solving, when you're doing the square rooting, you have to do the plus or minus, okay? Now, to piggyback off of that last example, why do we know to square root? Well, remember, there's really a 2 here, right? Even though we never see it in the textbook, we know there's always really a 2 there because that's the square root. Squaring a square root, square rooting something squared undoes itself and gives you x. So what if I had something like this, x to the third equals 8, and I ask you to solve that? What would you do? You wouldn't take the square root, because this is a 3, you would take the cube root. So you would take the cube root of both sides, right? And we'd get x equals 2, because I know that 2 times 2 times 2 equals 8. So whatever the exponent is, when you go to solve, when we get into solving, we'll get into it later, a little bit more advanced problems, but the basics, if this was x to the 4th, that means you take the 4th root of both sides. So just be cognizant of that as you start to move forward. Okay, so we run into this little situation here, and sometimes this is challenging to kind of understand, but I tried to give you an example here that make things hopefully make sense a little bit. So we know that when we take the square root of something squared, it undoes itself and we just get 3, right? So I have 3 squared in here, which we all know is 9. When I take the square root of 9, I get 3. Or the other way you could think about it is, if I square root something squared, those two undo each other and I'm just left with the radicand underneath, which is 3. So the question is, does this work all the time for all situations? And the answer is no. And here's proof. If you have you have negative 3 squared. Now you know that negative 3 squared is still positive 9. Right? Negative 3 times negative 3 is still positive 9. But according to what I just said up here, which we know is mathematically correct, that when you square root something squared, it undoes itself and you're just left with what's underneath. Does that equal negative 3? And it doesn't, right? Because we know that negative 3 squared is 9 and the square root of 9 is 3. So how do we fix that? How do we fix that situation, or how do we know when to do that? Here's how we fix it. When you have an even, when you're taking the square root or the 4th root or the 6th root or whatever something's even, and the exponent underneath is even, and you get an odd back out, then you're going to put absolute value bars around it, okay? So that we don't have this situation, because what we'd want here in this situation is when we undo it, when this 2 here and this 2 undoes itself and we get negative 3, we know that's not the case. So how do we fix that? We have to do this so that it turns into 3, which we know is the correct answer, right? Because we know the square root of 9 is 3. So here's a way to remember that, and then we'll try some problems and hopefully it makes a little bit more sense to you. Here's what you need to remember, and this is important. If your index is even, and the radicand has an even exponent, and the result of that is an odd, then we need to put absolute value bars around it, okay? So again, this situation here, remember the exponent on this negative 3 is technically a 1, so I went from even, and I got an odd exponent as an answer, therefore I need the absolute value bars so that I can get a positive 3, okay? So let's take a look at some examples and try to put this into play a little bit here. So we're just evaluating here. A lot of times you won't see the 2 there. We put this in our notes so that we can kind of overemphasize that you're taking the square root. Well, you know what the square root of 16 is, right? The square root of 16 is just 4. We talked about this earlier on page 1. If I have x to the 6th, and I'm taking the square root of x to the 6th, that means that's going to be x to the 3rd, okay? I'll have some students who will break this up. They like to break things up, and they'll do it like this. So they'll break up the numbers and the letters, and they'll go 4, and they know the square root of x to the 6th would be x to the 3rd, because x to the 3rd times x to the 3rd is x to the 6th, and there's our answer. Now, let's take a look at what happened here. Applying this principle right here, even, odd as an answer, let's take a look at what we have. I'm taking the square root, so I really have a 2 here. That's even. This 6 is even, and what did we get as a result? We got an odd. 3 is odd. So how we write this answer is like this has to be in absolute value bars. The x has to be in absolute value bars. Oops, excuse me, it's got to be 4x to the third. I put that in absolute value bars. Okay? So this is our final answer, again, because I went even, and got an odd. Okay? Let's try another one over here. Why don't you go ahead and hit pause and try this one on your own and see what you come up with. Okay, so I'm taking, and if you want to split these up, you can. You're taking the 4th root of n to the 4th, and you're taking the 4th root of y to the 8th. Okay, this might be helpful visually to see this. So what's the 4th root of n to the 4th? Or what times what? 4 things, 1, 2, 3, 4, that multiply together to give you n to the 4th. That's just n. Now there's really a 1 there, right? So you have an even, and you got an odd. So in my answer, I'm going to have n. I know I'm going to have absolute value bars around that. Over here, y to the 8th. Remember, we're just taking this number and dividing it. So I'm taking the 4th root of y to the 8th. I'm pulling out groups of 4. There'll be 2 groups of 4, so that'll be y squared. Now, I don't need absolute value bars around this because I have even, and I got an even out. So this would be my answer right here. Okay? I want you to try these on your own, on the back, see what you come up with, and then we'll talk through them and go over them here in a second. Okay, so we need to break down 128. So we're going to break this down just like we did if it was a square root, even though this is a cube root. So I just go 2 and 64, right? 64 breaks into 2 and 32. 32 breaks into 2 and 16. I got 2 and 8. I got 2 and 4. And I got 2 and 2, right? We always circle our prime numbers. Now, common mistake that students are going to make here is they're going to look for pairs. Well, that's only if we're taking the square root of a number. We're taking the cube root, so we're looking for groups of 3, not groups of 2. We're looking for groups of 3 because this is a 3. So 1, 2, 3. That's one group of 2's. 1, 2, 3. A second group of 2's. And then I have this lonely 2 all by itself. So right now I have 4, okay? And then I'm going to have a square root of 2 left over. Now I still got to mess with my variables here. That's why I left a little bit of space. So x to the 7th, I'm taking the cube root of x to the 7th. So again, I use division. 7 divided by 3. That's 2 with a remainder of 1, right? Because 3 times 2 is 6, so I'm going to have x squared. And then I'm going to have 1x left over. And then 3 divided by 3 is 1, so I just have one group of 3 y's, so that would be y there. Now, do I need to put absolute value bars around anything? I don't. And I know that because this is an odd number. The only time you're doing absolute value bars is if you have your index being even. And this is even and this is odd. So right away I know because this is odd that this is my answer. I don't need any absolute value bars. Okay? Now, sometimes you'll get a problem like this. There's a big giant 3 out in front. So it's really 3 times the 4th root of 432 n to the 4th m to the 8th. Okay? And all that means is whatever number you pull out of 432, you're going to end up multiplying it by 3. This is just like a coefficient or a constant out in front. It's not really a coefficient because there's no letter, but it's a constant number out in front that you're just multiplying at the end. So let's break down 432. If you need your calculator, 432 divided by 2, I get 216. 216 divided by 2 is going to give me 108. 108 divided by 2 is going to give me 54. 54 divided by 2 should give me 27. And then 27 breaks down into 9 and 3. And I got 3 and 3. I always circle my prime numbers. So you should have something that looks like that. Now, what are we looking for in terms of groups? This is the 4th root, which means you're looking for groups of 4. So 1, 2, 3, 4. There is one group of 4 2's. I don't have 4 3's. So all 3 of these need to get put right back underneath my 4th root. Sorry, I just looked at my answer here. There needs to be a 3 there because if this is a cube root, my answer's got to be cube root. Sorry, I forgot about that. So because there's not 4 of these 3's, these have to go back in here. So remember, this is all multiplication. So 3 times 3 times 3 is 27. Goes back underneath. Now let's look at our letters. N to the 4th. Well, I'm looking for groups of 4, or we just divide. N to the 4 divided by 4 is 1. Now look it, index is even, that's even, and I got an odd because there's really a 1 there, so this gets absolute value bars around the end. Okay? M to the 8th, so 8 divided by 4 is 2, so I get M squared. Now, I don't need absolute value bars around that because I have even, even, and even, so this is my answer. I'll clean that up a little bit for you so you can see it. So it's 2 absolute times the absolute value of n, and then m squared times the 4th root of 27. And then I almost forgot, remember there's a 3 out in front, so this 3 just gets multiplied by that 2, so my final answer becomes 6 absolute value of n times m squared times the 4th root of 27. And that is my answer. Okay? Quick application problem, real basic. It kind of goes back to solving. This is actually true. The weight of an orange can be found using this equation. W equals d cubed over 4, where d is the diameter in inches and w is the weight in ounces. What is the diameter? So you're solving for d. What is the diameter? What is the diameter of an orange if the weight is 5.5 ounces? So we put 5.5 in for w. I have d to the 3rd over 4, and we're solving for d. So we just cross multiply, turns into a proportion. So 5.5 times 4 gives me 22. I get 22 equals d cubed. Now how do you solve for d cubed? Well, I always go back to this. What if it was d squared equals 4? What would you do? You'd take the square root of both sides, right? Because this is squared, so remember there's really a 2 there, and you get d equals 2. Well, if it's cubed, we have to take the cube root. So we'd go here and take the cube root, and we'd go here and take the cube root. That's going to give me d, and then you can do this in your calculator. So 3 second caret button. So again, you have that. Type in 22, hit equals, and you get basically 2.8. So your diameter would be 2.8. Okay? So I got a lot going on. This is a very difficult section, especially if you haven't had Algebra 1 in a couple years. So I'm expecting a lot of questions, and that's perfect. I'd be happy to go over some more questions. Even if we need to go over some of the in-class assignment together as a group, I'd be happy to do that with you just to get clarification. The more you do of problems like 7 and 8 and 6 and 5 on the backside, the more comfortable you're going to get. Okay, and I can also give you some alternative ways to think about it in class. All right, take care.